Hello everyone. In this lecture, we will see what all are the different tests that we are supposed to do on the hardened concrete. We'll try to understand them, and we'll also try to see how the compressive strength test is done on the cube. So coming to the test on hardened concrete, we have a compressive strength test, then we have a flexural strength test, and then we have a split tensile strength. So these are the molds what we require. If you want to do a cube test, you require a cube. If you want to do the flexural strength test, we require this beam, and this is how that beam will be casted. And if you want to find the tensile strength of your concrete, then we have to make use of this cylinder, and this is how a cylinder is casted. Now for compressive strength test, you can see a cube has been prepared, and you try to apply a compressive load here. Let me do it here. So this is a compressive force from here, and here also you're applying a compressive force, and as a result of that, the cube is going to break. So this, the point at which it breaks, it will give me the compressive strength test. We'll try to see this in detail, but as of now, this much is enough. This is my flexural strength test. I'll be preparing a beam something like this. I'll keep it horizontally. It will be subjected to a 2-point loading, and we try to apply a force. Exactly wherever there is a pure bending, the crack is going to form, and this will give me the flexural strength of my concrete. And the last is a split tensile. So you can see, no, for the split tensile, I need to prepare a cylinder something like this, and I'll keep it in this way. I'll apply a compressive load, so a crack is going to form, which will be tensile in nature, and this will help me in identifying the tensile strength of my concrete. Now we'll start with compressive strength test, how it has to be done, and the methodology we'll try to understand, and the flexural and the split tensile we'll try to see them in the other videos. Yeah, so coming to the compressive testing of a concrete, the aim is to find the compressive strength of a given concrete cubes. Why we find the compressive strength? Because we know that my concrete is strong in compression and it is weak in tension. So if my concrete is strong in compression, how much amount of compressive load it is able to take on it, so that I can decide the grade and the strength of my concrete is called as. That is the reason we try to do this test. Apparatus, we require compressive testing machine, the molds and the other thing, we'll try to see them. Coming to the theory, concrete is a material which is non-uniformly stressed when subjected to the external loads. The stress in a cube of compressive strength concentrates on the hardened particle having high modulus of elasticity. So the axially loaded concrete cube carries a compressive stress parallel to the direction of the load. Axially in the sense you're applying a force from here and also from here. So in one direction, you're axially or adding a force. So the concrete in the compression test fails due to the lateral rupture of the concrete. So this is that mold what you have to use. This is the cube in fact, and the size of the cube will be 15 centimeter is the length. The height will be 15 and the width is also be 15 centimeter, which comes out to be 150 mm. So to put it in a better way, this is my compressive testing machine. You can see it here as well. And these are the cubes where I have prepared my concrete. Coming to the equipment, 150 by 150 by 150 is the size of the mold, and 300 cylinder. So one thing we need to understand, we don't use cylinder for in India especially for doing the compressive strength. But if you go to North America, I mean if you go to the United States and all, instead of cube they do the test on the cylinder, right? Then you require a standard tamping bar, you require compressive testing machine. So these are the cubes, and this is how we try to fill the concrete in the cube, and so on. Now one thing we need to understand, we have two different sizes of the cube. One is, as you can see, 150 by 150 by 150, and sometimes we have 100 mm also, that is 100 same. This is 100, the breadth is also 100 and the height also will be 100. In which circumstances we need to use them? Just very simple. So if you're using a size of an aggregate, if my size of the aggregate is 20 then we'll go with 150 by 150 by 150 cube. And this is usually what we follow in our college labs and also in the practice during the execution, even at the site and everywhere. But if you're using an aggregate less than 19 then instead of 150, the code says that you can make use of 100 by 100 by 100 size of a cube, right? So whenever you're using a size of aggregate less than 19 for the road works and all, usually we go with the 10 12.5 In that case, you can try to make use of the 100 cube if you want. But normal practice, what we follow is 150. So that is why whatever explanation I'm gonna do from here onwards, it will be limited to 150 by 150 to 150, right? But the way you prepare the concrete, everything remains the same. Only the change is you have to change the size of the mold if you're using a aggregate size lesser than 19 right? Yeah. I hope these things are clear. Now we'll move to the preparation of that, how this test has to be done. So it's very simple. First is take required quantities of materials which are predetermined. The material should be sufficient to cast at least 4 cubes and 4 cylinders. Forget about the cylinder. We'll try to do only for the cube. If you're using a cylinder, you can do that. What do you mean by this? First, we have to decide what grade of concrete you're going to prepare. Let us say I'm preparing a M25 grade. Now, why this M25 only? Why I'm not taking M20? We'll come to that a bit later once we finish this. There's a big theory behind that, right? M20. So this is done. For based on that, you try to identify how much cement, how much coarse aggregate, how much fine aggregate, and what is required. With the help of that, you prepare a concrete and you cast the cube. So the mixing of a materials may be hand mixing or by machine mixing. In hand mixing, cement and sand are thoroughly mixed until the mixture is of uniform color. The coarse aggregate is then added and dry. And this is how you have to do. We'll not try to get into this. It's very simple. You have to just mix. The entire meaning of this is you have to mix it properly. That's it. Now coming to the third thing. Before assembling the mold, a thin layer of oil must be applied to the inside surface of the mold in order to prevent the sticking of concrete to the mold, right? So we'll try to apply the oil to this so that when you do demold it after 24 hours, we'll find it easy for the concrete cube to take it out. Else, since otherwise, if you don't put the oil here, this steel, the mold and the concrete will have a good bonding between them. As a result of that, you'll find it very difficult to take out. So in order to stop that bonding, we'll try to apply this oil. Yeah, the next point is that the concrete should be filled in mold in 3 equal layers. Each layer should be compacted for 35 times with 16 mm diameter tamping rod, 600 mm long with a bulleted point at a lower end. When the cylinder is used, the strokes for each layer should be less than 30 mm and strike off the surface with a trowel. Yeah. So what it's trying to tell, when you fill the concrete in the cube, you have to fill it in layers, right? So how do you decide that? If you refer Indian Standard Code books, it says that you have to fill 5 centimeter at single time, right? So you have to fill, let me write it here. I'll write it here. 5 centimeter will be your each layer. Now, now imagine that the size of my cube is how much? The size of my height of my cube is 150 mm. So, right, which comes out to be 15 centimeter, right? Yeah. So 5 centimeter each time. That means you have to fill this mold in 3 layers, 5 centimeter once, 5 centimeter twice, and 5 centimeter thrice. Only then you will be finishing 15 centimeter, which is the height of my mold. That is a reason it is written 3 equal layers, right? Yeah. So first we'll fill it in 5 centimeter. We'll do the tamping with the help of a rod so that there is no voids and all. Again, we are going to fill another 5 centimeter. We'll do the compaction again. Another 5 centimeter. We'll do the compaction. So hence 3 equal layers. Now, another question that comes in our mind, what if I'm using a 100 mm cube? Now, this is 150. Suppose if I use a 100 mm cube, in that case, I need to do only twice. My each layer will be twice. That means because 5 centimeter is my filling for each layer, right? Since the height itself is 10 centimeter. So first I'll do the tamping. Then second layer, I'm going to fill it off. If I'm using a 100 centimeter cube, since we're using a 150, we have to fill it in 3 layers. That is what you mean by this point. Yeah, right. And then if there is an excess concrete, you have to strike it off. And also remember, here it is written, you have to do striking for 35 number of times if you're using a 150 mm cube. Just in case if you're using a 100 mm cube, in that case you have to do tamping for 25 times, right? Here you have to do 35 times. If it is a 100 mm cube, then you try to do for 25 number of times. That's it. Once all these things are done, you have to strike off the excess concrete if there is any. And once that is done, you can see here, no, these people have a, okay, these people have a casted the entire cube and the striking of the excess concrete. So once this is done, next day you have to come. Okay, let us say now you are doing the concreting of this. Next day you are going to come. You are going to take it out. You are going to do the demolding of this. Take it out. Immediately try to keep it in the curing tank for curing purpose. This is how you try to keep them in a curing tank, right? So you have to cure it for 28 days, and only 28 days we'll try to take it out and we'll try to apply the force on that, and we'll try to see whether my concrete has gained the strength or not. So usually the usual practice is that we have to do the testing on 7 days, Let me write it here. We have to do this testing on 7 days and 28 days. In some labs also we try to do it on 3 days also. But the general practice what we follow is you can go for the 7 days and you can go for the 28 days. But the final strength which we take for our calculation is the 28 days, because based on the 28 days strength only we'll decide what grade we want and all, right? So this is how the entire process of a cube testing has to be done. Yeah. So now coming to the testing part. So this is how it is. We'll apply a compressive load as we already seen. And one thing we need to remember, when we try to apply the load has to be applied at 14 Newton. Let me write it here. The load has to be applied 14 Newton per mm square per minute. This is a, I mean, that means you have to apply gradual load. It should not be an impact load. Slowly you have to keep on increasing the load, so that what will happen? The concrete will fail in crushing, and that crushing failure will give me the compressive strength of my concrete. So this is how the formula is written. Stress is equal to force upon area. So P is that compressive load at which the cube fails. A is a cross-sectional area of a specimen. We know the size of the cube is 150 by 150 by 150. Based on that we have to find the area. So area comes out to be 22500 mm square for a 150 mm. And if you are going for a cylinder, this is how it comes out to be. For cylinder, since it is a cylinder in shape, we have to put a formula for areas pi by 4 into d square, where the diameter of my cylinder is 150 mm square. So try to do this, right? But for our calculation we have taken cube, so we'll be taking this particular value of 2250 mm square as a value for the calculation. And finally, this is how we try to do it. Let us say after applying certain force, your cube has failed. So you'll try to take out the cube and try to note down at what value it's going to fail. So this is how they're written. They've taken two cube, but actually they were supposed to take three. They've done a small mistake here, but we'll learn from this mistake only. So you should have taken three here, minimum three sample you have to take. So they have taken this load at failure. Cross sectional area, we are getting it from here, 2250. Same thing we are going to find it here. So what you need to do, stress is equal to force upon area. That is load, they are getting it from here, 1059,480, and divided by area. Area is here. You get this as a strength of my concrete. I've done it for this. Similarly, do it for the second cube also, the same thing. Similarly, you are going to get another cube. You have to do it for the third cube also. So once you do for the three cubes, out of three cubes you have to take the average of that, and that average will give you the characteristic compressive strength of my concrete. So to put it in a better way, we'll quickly do that. Let us say in the first sample you got a strength of 47, right? Yeah. In the second sample, 47 Newton per mm square. In the second sample, we'll take this sample only. In the second sample, it has got 13 Newton per mm square. And the third sample, you are getting some 25 Newton per mm square. Now try to take the average of this. The average will be 47 plus 13 and plus 25. Since we are taking three cubes, we'll divide it by 3. And if I try to do it manually, I'll be ending up by getting 47 plus 13 plus 25 divided by 3. So I'm getting 28.33. So 28.33 Newton per mm square is my strength of the concrete. Now I have to check for what grade my concrete was designed, right? Let us say I had designed this concrete for M25 grade. Let us consider. For M25, I had designed this concrete, and finally after testing I got the strength as 28.33, which is greater than 25. That means whatever testing I have done, it is correct. Suppose instead of M25, let us say I had designed my concrete for M30, and finally after doing the test I found that at the end of 28 days my concrete is not able to gain the strength of 13 Newton per mm square. It's getting 28.3, which is less than 13 Newton per mm square. That means whatever test I have done, it's a wrong. I mean, the mixed design what you have done is not correct. You have to do the, either you have two option, either you do the testing once again, maybe while applying the load or maybe while doing the sampling of aggregates and all, the proper quality was not ensured. Otherwise the second reason may be about your mixed design. Now what is that mixed design? We'll try to see that. So this is the reason for that, right? So this is how it has to be done completely. Yeah, right. So this was entire procedure of a uh, compressive strength on the concrete. And one more point, whenever you try to do the load on this, the final value should not deviate by 10 or 15% of the mean value. That means, what I'm trying to tell is, because these are the practical things, because simply by doing the cube testing will not help us. We need to understand the fundamentals of this. Let us say, uh, in the first cube you got a result as 25. I'm taking it some random number. Second cube I got value as 13 newton, 30 newton per mm square, and third sample I got it as like 32. Now again, if I take the average of this, quickly do that. 25 plus 30 plus 32, I'll divide it by 3. I'm getting 29. So my average strength is 29 newton per mm square. Now this 29 answer what I'm getting, and this answer what I have, they should not deviate by 15%. That means, yeah, that means, now if I have taken average of this, the average comes out to be 29 newton per mm square. So this value should not deviate by 15% of your mean. That means, take a 15% of this. If I take 15% of this, 29 into 15% is 4.35. So plus or minus, no, for this 29 you minus 4.35. This is my average. From average it should not deviate. From 29 minus 4.35, I'm getting 24.65. On the other hand, plus or minus, now you add it, 29 plus 4.35, 33.35. So this is a range for my values. Now this value what I'm getting, let me put it in this way. This ranges what I'm getting, 24 and 33. So this is the range what I'm getting. So whatever samples I've got, this value should not deviate from here. Now we'll try for 24.65. We'll try to see whether any of the cube out of these three has a value less than 24.65. This is 25, this is 30 and 32. That means it is more than 24.65. So this condition is okay. Now for now we have done it for minus 15%, that is minus. Now for plus 15, 33.5, we should make sure none of the cube is passing, is getting a strength more than 33.35. So this is 25, which is less than 33.35. 30 is also less than 33.35. 32, which is also less than 33.35. That means whatever test we have done, no, that is good, and there is no much fluctuations in the value. Just in case if there is a fluctuation, then we have a separate criteria for that. We'll not try to get into that criteria. As of now, this much is enough. Now why we have to do all these things, that question comes, right? The reason is that the concrete what we have taken, no, my concrete is a bit heterogeneous. Okay, heterogeneous. That means we don't know the actual nature of a concrete, right? What, let us say I'm giving you two options. I'll Let me prepare one concrete on this side with same content and all, and you prepare another concrete from this side. So there will be a lot of variation in the way we mix, the way we prepare the concrete and all. So if I do a cube test on this, I am going to get a separate answer. If you do, if you do a cube test on the sample what you have prepared, there also there will be variation, right? But ultimately that has to be used in the structure, so we should be try to be more safer. So that is why all these criteria are made, that your final answer should not vary by plus or minus 15%, because based on the cube strength only will decide what should be the other based on the cube strength only will decide how much my structure has to go, and all those things. That is the reason the cube strength plays a very important role, and that is why all these rules has to be followed, right? So with this, we have covered most of the things regarding the cube testing, how it has to be done, how the values has to be taken into consideration. And also there are other points also, I'll quickly tell that. When you try to apply the load on this, you have to make sure you're putting these platens exactly horizontal. They should not be, this should not be inclined. The cube also should be properly casted 150 by 150 by 150. There should not be variation. There are a lot of things, but as of now we'll not try to get into that. Yeah, now the main question is that how do you decide the grade of a concrete, whether you have to take M20, M25, those things. For that, even before we start with the work, we have to do the mixed design. That means, anyhow we'll be taking up this mixed design in the chapter 3. But as of now, let us say I want to prepare M40 grade of a concrete. For M40 grade of a concrete, we'll do all this calculation, how much coarse aggregate, how much fine aggregate is required, and finally we come to a conclusion that This will be my ratio. That means cement I require 412 kg per cubic meter, water I require 148 kg, fine aggregate 648, coarse aggregate 1234, chemical admixture so on, and my water cement ratio will be 0.36. Based on this, we'll try to find how much amount, what should be the ratio of my concrete, and that ratio, based on that ratio, do we try to do the cube testing. And finally, when you prepare a cube out of this proportion, the final value of your cube should come more than m40, that is more than 40 newton per mm square. Only then we can say that whatever mix we have prepared here, no, this mix what we have prepared here, it is a right mix, and we can try to make use of this mix in the construction. Just in case if it is not able to satisfy this value, then what we need to do is we have to try to adjust this. Instead of 412, we have to increase the cement content, we have to decrease the water cement ratio, all these things we have to try to do the recalculate all these things. So in this way we try to decide all these things. Now how to decide this, m40 only is required. For that we have to go for Indian standard 456 code book. So it depends on what is the exposure condition where you are constructing your building. If you're constructing a building in a normal area which is not very uh, close to the seashore and all, then you can take it as a mild or a moderate exposure. This is that exposure condition. Suppose if you're constructing your building somewhere to the coastal area, so it comes in the very severe condition, that is concrete exposed to coastal environment, concrete surface exposed to sea water, spray, corrosive, severe freezing conditions and all. So if it is a very severe condition, in that case the minimum grade of a concrete what you need to use is given by the Indian standard. That is, I'll show you how it is. Very severe is my condition, it is here. This is my very severe condition, and we are going for RCC. For under the RCC, you try to see it here, reinforced concrete. This is plain concrete. We are not doing PCC, we are doing RCC. For under the RCC, the minimum grade, what the code is telling us is you have to go with M35 grade. This is the minimum what you have to go. Now for this M35, what we do is based on the condition, we try to prepare this mixed design as I showed you. So here it will be M35, based on the, all this will be decided, and based on this final value will be achieved, and then we are going to do the cube testing. So all these are the things that we try to play behind doing the cube testing, right? Yeah. So I hope I was able to convey how these things has to be done in a more detailed way. So in the next lecture we'll try to see why is that in India we do cube testing, and why is that in Americans they do cylinder test, and which is better, what is the logic behind that and all. And then we'll try to take up the other two tests, that is the flexural strength test and the split tensile strength. So we'll see you back in the next lecture. Thank you.